All right, in this problem, you're asked about concentrations of ions in solution when we mix two solutions together. So we're going to be mixing the 600 milliliters of calcium bromide with 800 milliliters of aluminum bromide. Before we work through all of this, I wanted to make a point of mentioning that on the quiz, we would only ask you about one ion concentration. And this type of example would probably be bromide ion. But for practice, we're going to go through all three. First, let's review the dissociation reactions. So we see there's two sources of bromide ion, the calcium bromide and aluminum bromide, but calcium only comes from calcium bromide and there's only one source of aluminum. And all of these ions are in a new solution, and the total volume of the new solution is 1.400 liters. Okay, now that we have a good grasp of physically what's going on here, we can figure out the concentration of each ion. First, let's take the calcium. Concentration will be given by moles of calcium ion per liter of solution. We want to calculate each of these values. We want the moles of calcium ion, which comes from only the calcium bromide here. So this is where we get our calcium ion. Okay, so this much of the calculation here tells us the moles of calcium 2 plus ions that are in that solution. As we see, our liters cancel and the moles of calcium bromide cancel. So that gives us the moles of calcium bromide, but now we are in 1.400 liters of solution. So we churn through all these numbers and we get a result of 0.17143 moles per liter. Now with justifying 3 sig figs, that's equal to 0.171, and this is for calcium, moles calcium 2 plus per liter. Okay, when we do our bromide, we need to calculate how many moles of bromide we generate from each solution. All right, so we can calculate the moles of bromide ion we get from the calcium bromide and the moles we get from aluminum bromide. Now make sure you're paying attention to these mole-to-mole ratios. As we see from our dissociation reaction, every mole of calcium bromide gives us 2 moles of bromide ion, and for aluminum bromide, that factor is 3. Now we can add these together and divide by the total new volume. And here I've done that, so the total moles of bromide ion is obtained by adding the moles from each source together, dividing by our total new volume. Now the last ion concentration can be obtained by looking at the aluminum bromide. Now the last ion concentration is aluminum, and we'll look at the aluminum bromide for that.